Today, I'm going to be talking about transformer market development and future trends, and I'm going to be focusing on the Asia Pacific region. Let me take you through the agenda for today's presentation. I'm going to start off by giving an introduction of power technology research. I'm going to then talk about the global transformer market and then zoom into the transformer market in Asia Pacific region. I'm then going to discuss market opportunities for transformer enterprises. And within this section, I'm going to be covering the growing demand for electricity because of electrification and industrialization. And then I'm going to be talking about the energy transition that is not only happening globally, but also in Asia Pacific region. And specifically within that, I'm going to be covering clean energy and electrification of transport sector. Lastly, I'm going to be discussing the future development trends of transformers. And within this section, we're going to be talking about digitalization of power grid and transformers, and then exploring the alternatives to mineral oil. Let's start with the PTR company overview. To start off with the company introduction, Power Technology Research is a market research company that focuses on two key areas, power grid and everything in and around the power grid. So these are the topics that we cover on the global level. So starting from legacy grid equipment, transformers, switchgear, flexible AC transmission system, HVDC, and synchronous condensers. We also cover substation automation, DC power grid, and within that, shore power and shore to ship power. We also cover smart meters, power factor correction, and grid communication. Towards the right-hand side, movement is happening as far as the power grid is concerned. So EV charging is the main topic that interacts with the power grid directly. And since EV charging infrastructure is being covered separately as a separate service than the power grid, we use both these services to understand the interconnection between the two. Moving on, storage value chain is a very important piece of the puzzle, and a combination of all three is something that we study. There's a lot of discussion around the electrification of electric vehicles, but beyond that, electrification is also happening in commercial and off-highway vehicles as well. Research from this topic then gets plugged into many other areas. Finally, the two topics that we cover on rotating machines are EV traction motors and industrial motors. Now, to answer the question of what are we exactly covering in these topics, so a lot of research that we conduct is bespoke and custom. So this is basically where we look at what the customer has requested, what is their demand, and then try to answer that through our research. It varies from market sizing to competitive analysis to market accessibility. Oftentimes, we're providing a combination of all three or maybe a deep dive into one of these areas. Within market sizing, understanding what has happened in the past, if you're comparing technologies against each other, then you're looking at historical data because that's a very crucial thing and it helps you understand the outlook as well. Then a key factor that we look into is the competition between technologies and application areas because growth is not supposed to happen in all areas in the same manner. So we try to understand each separately. In competitive analysis, we try to understand the main players in the market in terms of market shares, SWOT analysis, and benchmarking. Market accessibility is where we try to understand how the business is basically done. So our research is done on country level and we are understanding how business is done and how businesses are operating at that level of granularity. Starting from business practices, we research what kind of regulatory framework exists, what are the product and market trends, and what is the sales channel. Oftentimes, we have package reports where we combine all of these topics, or sometimes as per the customer's request or demand, we do a deep dive into the topic of interest. Now, to do a deep dive into how transformer research is being conducted or power technology research, we cover application where growth is expected from power and distribution transformer, and these are the transmission and distribution sector, the generation sector, and the industrial sector. As I discussed earlier, after this, we do a slicing of the data to see which technology will experience growth in the future, and then the segmentation of data is done in terms of the insulation, medium, and voltage, and then we look at the install base to understand the historical trends, and then we look at the new additions to see what will be added in the future. Now let's talk about the global transformer market, and we're going to be looking at the investment data that I have taken from IEA from the World Energy Investment Report 2021. So if you look at this investment in the power grid data for years 2020 and 2021, there are a couple of things that stand out. One thing that is immediately clear is that the investment in 2021 is greater than the investment in 2020. And now that can be explained by the need to expand and upgrade the grid infrastructure, and this need arising from this growing generation capacity and a growing network of charging infrastructure as the electric vehicle fleet grows globally. Another important thing to note is that while this is also true for transmission and distribution, with the level of investment being higher in 2021 as compared to 2020 for both these sectors, the spending or the investment in the distribution sector is higher than the spending or investment in the transmission sector in both these years. Now, here I would like to highlight why that is the case, because a lot of this expansion and upgradation of the grid is being done in response to the growing generation capacity coming from renewables and the growing charging infrastructure, which is being installed or deployed in order to support a growing electric vehicle market. Most of the impact is experienced at the distribution level, which is why the need to prepare the distribution grid to account for this energy transition or to support this energy transition is quite important, which is why we are also going to be focusing on the distribution grid when we talk about Asia Pacific market in specific. In the future, we can expect a similar trend because the world is undergoing an energy transition, and this is having a direct impact on the power grid, and this will call for investments in the power grid, both transmission and distribution sector. If we talk about the Asia Pacific market specifically, in 2021, the distribution transformer market size was about $7.1 billion, while the power transformer market accounted for $11.5 billion. And the total transformer market in Asia Pacific accounted for about 50% of the total global market, which is a huge share. So it's safe to say that movements in this part of the world, in this region, will have an impact on the entire world because this market accounts for 50% of the total market, which stood at $37 billion in 2021. Now, zooming into Asia Pacific distribution transformer market, there are a couple of things that I want to highlight. So first, let's look at the growth trend that is expected in the future. So right now in 2021, the Asia Pacific market is standing at $7.1 billion, and it is expected to grow at a CAGR of 6% approximately and reach a value of $9.5 billion in 2026. So in the next 5 years, we can expect the Asia Pacific distribution transformer market to grow at a fast rate. If we talk about the market in terms of its global share, so in 2021, the distribution transformer market accounted for 51% of the total distribution transformer market globally, and this share is expected to increase to 54% in the next 5 years. If we talk about the technology split of the distribution transformer market in Asia Pacific region, in 2021, 89% was oil type, oil immersed distribution transformers, and the rest were dry type transformers. If we talk about the vertical split, we see that most majority, which is equivalent to 90% of the distribution transformer market, is driven by the utility sector, followed by industry and then generation. If we then zoom further into the region, we can highlight the two key markets which have the highest volumes in the region. China with $3.1 billion and India with $1.1 billion market in 2021. Now, not only does India have a huge volume in terms of its market size, but it is expected to grow at a very fast rate in the next 5 years. And the expected growth rate is around 11% or 10.7% to be specific. China is also one of the highest, actually not one of the, it is the market with the highest volume in the region and is also expected to grow further with a CAGR with a growth rate of 3.1%. Now let's move on to talk about the market opportunities for transformer enterprises. Within this section, as I mentioned before, we're going to be talking about the demand for electricity coming from electrification and industrialization, then the movement around clean energy and electrification of the transport sector. Growing demand for electricity, first we're going to discuss electrification. So while there are a lot of countries within the region which have been able to achieve 100% electrification, there's still many developing or underdeveloped countries that are yet to achieve 100% electrification or have a population that has access to electricity. So if we talk about a couple of countries, in Nepal, 89.9% population has access to electricity. This percentage is equivalent to 96.9% in Indonesia. In Afghanistan, it is 97.7%. In Bangladesh, it is 96.2%. In India, it is quite a better situation with the electrification rate of 99%, and in Pakistan it is 75.4%. And the point of sharing this information with you is that there's still huge chunks of population that are without electricity, and while these countries are putting in the effort to provide access to electricity and to reach 100% electrification rate, it's going to lead to expansion and additions in the power grid, which is then going to drive the demand for distribution and power transformers. If we talk about industrialization, in industrialization, we know that China has been a manufacturing hub in the region. However, in recent years, there has been movement in other countries like Malaysia, Indonesia, Vietnam, Japan, and all of these are now also becoming industrial hubs for not only the region, but for the global market as well. So if to share some examples with you, for instance, Intel Corp has announced an investment of around $7 billion to build a new chip packaging and testing factory in Malaysia. Foxconn is building a factory in Indonesia with an investment of $1 billion. Taiwan is also announced its first ever chip plant in Japan. Samsung Electronics is also setting up a factory in Indonesia with an investment of USD 1 billion and also establishing a manufacturing base in Vietnam. And Lego has also announced an investment of $1 billion to set up a manufacturing facility in Vietnam. So when all of these industries are being set up in the region, this is again going to drive up the demand for legacy grid equipment, which will include transformers. So this is also one area where transformer enterprises can capitalize on this opportunity. Talking about clean energy, let's look at some figures for renewable energy and let's look at what the situation was historically, that is in the last 4 years, and what is expected to happen in the next 4 years. So if we talk about the total renewable capacity additions in Asia Pacific region, in the last 4 years, 438 gigawatts were added. However, in the next 4 years, a capacity of about 717 gigawatts is expected to be added. And this is going to be 64% higher than the capacity additions in the previous 4 years. If we break this down further and look at utility scale solar capacity additions, we see that there's also movement there with the expected additions in the forecast years from 2022 to 2026 expected to be 71% higher than the case in the last 4 years. Similarly, if we talk about wind capacity, again, in the next 4 years, the capacity additions will be about 55% higher than the capacity additions in the last 4 years. So this means that there's a lot of movement around wind and solar energy or renewable energies as a whole in the region. And what that is going to do is it's going to drive up the demand again for legacy grid equipment as utilities look to expand and modernize their grids, modernize the power grids in order to incorporate this not only additional capacity coming from renewables, but also this capacity which is variable in nature and calls for a multi-directional flow of electricity. Now, we've discussed the capacity additions, and these capacity additions are going to, these expected capacity additions are going to be added in the future years, and they're going to be driven by these targets that each of these countries have set. So to take some examples, in China, there's a plan to achieve 40% electricity from nuclear and renewables by 2030. South Korea has pledged that it's going to have 40% electricity from renewables by 2034. India is planning to add 500 gigawatts to non-fossil fuels and have 50% of its energy requirements fulfilled by renewables by 2030. Thailand has also set an ambitious target of having 25% electricity generated through renewables by 2037. Singapore has also pledged that it's going to add 2 gigawatts of solar energy by 2030 and then have another target that's for energy storage. Then for Japan, it has pledged and it aims to have 36 to 38% of power supplies from renewables by 2030. And these targets are what is going to uh, lay the plan or the strategy that is going to be followed in all these countries in order to integrate renewables into their generation mix, into their energy mix. Next, we're going to talk about the electrification of transport sector. These are some of the targets for both electrification and the charging infrastructure that is needed to support the growing electric vehicle base set up by different countries in the Asia Pacific region. So for instance, India has announced an investment of $125 million, and the aim of this investment is to have 10% of all new registered vehicles to be electric by 2025. In South Korea, they're planning to deploy 500,000 publicly available charging points by 2025. China has also set a target to increase its NEV sales to fourfold by 2025. Australia is also investing in electric vehicles, and the strategy that it has announced very recently aims that 53% increase in electric vehicles by 2030 to 2031. India has again also aim that it's going to have 70% of all commercial vehicles, 30% of private car, 40% of buses, and 80% of two and three wheeler sales by 2035. And Australia has also set out a future fuels and vehicles strategy, and it wants to achieve net zero emissions by 2050, which will also call for a lot of expansion of the electric vehicle base. Now, the point of sharing these targets with you is to drive home the point that there's a lot of movement in terms of electric vehicles. Countries are adopting electric vehicles and are pushing for electric vehicles in order to be able to achieve their climate goals, to achieve their net zero carbon goals, right? But what this means is that to support this growing electric vehicle base, there's going to be a growing charging infrastructure base as well. And that's how electric vehicles will be interacting with the power grid. And when they do, there will be need for modernization and expansion of the grid to support this integration and to support this adoption, which will again give rise to demand of legacy grid equipment, including transformers. So if you look at the electric vehicle chargers market, it is expected to grow at a CAGR of 24% from 2021 to 2030. Now, this is massive growth, and this massive growth needs to be matched with investment in the power grid, as I discussed earlier. If we look at the charges annual market from 2020 to 2030, we see that there's movement in all of these key countries like China, South Korea, Japan, Australia, and India. All of these countries are adding to their charges market and growing their base, hence giving rise to the need for expansion and modernization of the grid. Now let's talk about the future development trends of transformers. Within this, first I'm going to touch upon digitalization. So digitalization is imperative, and not just for transformers but power grid as a whole. And it is imperative because it is fundamental to support EV adoption and renewable integration. Now there are a couple of aspects to digitalization of the power grid that I'm going to discuss. So for instance, smart grid and smart charging, where the key is to collect data and then to use this data to have intelligent charging or to intelligently integrate and manage distributed energy sources, including renewable energy. Similarly, there's the aspect of multi-directional grids. So traditionally and specifically in Asia Pacific region, the grids are unidirectional with electricity flowing from the conventional power plants to the end user. But however, with the introduction of electric vehicles and renewable and distributed energy sources, electricity has to flow both ways, which is why it is important to have multi-directional grids. And this means that there's need for digitalization in order to maintain these networks. Then there's the concept of load management, specifically for electric vehicles, where there is passive and active charging. In passive charging, you shift your peak load to off-peak charging in order to, through time of use charging, in order to make sure that voltage is regulated. In active management or active charging, what you do is that you collect data and use algorithms to manage your charging process, right? So the key to all of this is the ability to collect data in the power grid. And to be able to do that, the equipment within the power grid needs to be smart and digitalized. And for that, digitalization of transformers is extremely important. And that's a trend that we can expect in the future as the energy transition moves along further on its path in the Asia Pacific region. So according to some data that we have from CIGRE, 75% reduction in repair cost due to early detection are achieved if you have digital transformers. Similarly, 50% reduction in risk of catastrophic failures, 60% reduction in repair cost due to early detection, and 2% of the price of a new transformer in cost saving. So what happens is that when you're able to collect all this data, you're able to carry out preventive maintenance, and this preventive maintenance gives you a chance to reduce your breakdowns, to lower your downtime of assets, to lower your maintenance and operational cost. And especially with the advent of COVID, which was unprecedented, we have realized the importance of working off site, of remote work. And in these cases, digital transformers will give the on site staff the opportunity to do remote monitoring, which will not only be beneficial in terms of some accidents, but also in other cases when they're unable to work from site. Lastly, I'm going to be talking about the alternatives to mineral oil. So utilities and governments and companies, all of these are now working towards having sustainable practices. So not only are they trying to achieve their climate goals, but they're also trying to have sustainable practices that can be taken into the future as well. And along these lines, there's a lot of talk around ester oil as a possible alternative to mineral oil. This is something that is being seen in Americas and Europe at the moment, but it is expected, or we can expect that this will also happen in the Asia Pacific region in the coming future. So because of its higher fire and flash point, ester has less chances, or less fire hazard, which will not only reduce your fire safety equipment, but also it will uh, be sustainable and more suitable for the environment. Similarly, it is biodegradable, it is non-toxic, which are also two factors which will support the notion that it is sustainable and climate and environment friendly. Similarly, its thermal aging is better than mineral oil, which will give it a longer lifespan. So because of these enhanced properties of natural ester, which are then further enhanced or adjusted in synthetic ester, it is being chosen not only over mineral oil but also dry type. So this is a trend that we can expect in the future in to grow in Asia Pacific region, as well as it is gaining traction in Americas and Europe at the moment.